Section 4.1 is where it finally gets unreal and we start to deal with these square roots of negative numbers. Those are called imaginary numbers. So let's get right to it. First of all, let's just review. The square root of 16 would be 4 because 4 squared is 16. And then earlier in the course we said the square root of negative 16 was simply not a real number, or some of you would say impossible or can't do. Well, now we're going to actually have a way to deal with this. So this we had said that was not real. The way we're going to deal with it is we're going to just declare a new variable, sort of like pi is 3.14159. We're going to say that I is going to be the square root of negative 1. So in italics, I is always going to represent square root of negative 1 in the world of math. So what that means is I can split this off into the square root of 16 times the square root of negative 1, which is really 4 times, and remember this is our I, so I'm just going to put an I there. We write the square root of negative 16 as 4i. We can go ahead and square root the 16 and get 4, but we can't do anything with the negative 1 under the radical, so we write the letter I to represent that. So on this next screen we have a few more examples. The square root of negative 121. Now 121 is actually a perfect square. It is 11 times 11, and then because we have that minus sign under the radical, we put an I there. It would be 11i. Now then the next one also has an I in it because of the minus sign. It also has an 8, and we have to bring out as many as we can. We have x to the third, so that means x squared can come out and it becomes an x, but that does leave one x under the radical, and then the square root of y squared would be just plain old y, so there's that answer. Now on the right side of the screen we see that if I is the square root of negative 1, what would we get if we squared that? If you square a square root, you get the radicand, so negative 1. So in our world where I is the square root of negative 1, I squared is going to be negative 1 always. Now what do you get when you take the square root of negative 1 and you raise it to the third power? Well, two of those would be what we just talked about. That would be our negative 1. And then we still have that extra 1 that's stuck under the radical. So the answer would be negative I in that case. Negative I is what we would write for I to the third power. Now, I to the fourth power takes that answer, which is negative I, and we multiply by another factor, a fourth factor, and we get negative I squared, which actually is positive 1. So we don't get negative 1. In that case, we get positive 1. So you kind of need to refer to the sheet every once in a while. I squared is going to be negative 1. However, I to the fourth would be positive 1. Now I to the sixth, it would go back to negative 1 again, and I to the eighth, it would be positive 1. So all the even exponents kind of go back and forth along the way. And then the third root and the fifth root will also go back and forth. Now we're going to do a little bit of simplifying, given that I is the square root of, and I squared, we just said was always negative 1. So whenever you see an I squared, I want you to think about replacing it with a negative 1. So in this first problem, 3 times 4 is 12, and then we get that I squared that I just mentioned. So we want to replace that I squared with negative 1. 12 times negative 1 is negative 12. The answer there would be negative 12. So look at that. We took an imaginary number times an imaginary number, and we actually got a real answer. That's why this can be useful in mathematics, because sometimes we're working a problem and we get this imaginary answer, but then maybe later in the problem you square it or something, and lo and behold, you get a real answer in the end. So you're actually able to solve it if you can maintain the imaginary number throughout. This would be negative 27i squared. Now remember, I squared is negative 1, so negative 27 times negative 1 is positive 27. 27, positive 27. All right, now this next problem, some of you may be thinking, oh, we're going to FOIL this, but actually this is an addition problem, so we don't FOIL when we add. All we do is combine like terms. So you may want to write that on your paper. This is simply combining like terms. So we're going to take 2 and we're going to combine it with the 3. That's called 5, of course. And then we're going to combine the 3i with the negative 8i, and that'd be negative 5i. I'm going to introduce another term here. This is called a complex number. Complex numbers have a real part and an imaginary part. So in this problem here, the 5 would be our real part, and then our negative 5i is called our imaginary part. And this is called a complex number. Complex number. All right, in the next question, we are going to have to minus everything in the second parenthesis. So it actually becomes negative 3 and positive 2i. We now combine our like terms. 12 and negative 3 makes 9, and negative 7 and positive 2i makes negative 5i. There's nothing else we can do with that. That's called a complex number. That would be our answer. As we look at this next screen, we see here we do have FOILing questions. So go ahead and write the word FOIL there. 2 times 4, that's your first, would be 8. Your outside is negative 3i. Your inside is positive 4i. And then the L, we get negative 3i squared. So a little alarm should go off in your head that I squared can be replaced with negative 1. So this ends up being positive 3, by the way, when that I squared is replaced with a negative 1. So our final answer would be 11 plus 1i, or just 11 plus I. 8 plus 3 makes the 11, and then 4 and negative 3 makes 1. Now in this next one, you should really recognize that these are the same binomials except one is plus and one is minus. That's called a sum and difference pattern. When you do a sum and difference pattern and you have to FOIL it out, you actually don't need to do the O and the I because you know they're going to add up to 0. 5 times 5 is 25, and then we have minus 4i squared. So that would be 25 plus 4, which is 29. So we do not get a complex number. We get a real number, 29, even though we multiplied two imaginary numbers. So there's an example where we could get back into the real world by multiplying two imaginary numbers together. This is the last screen of the notes, and what we're going to do is rationalize these. That means get rid of the radical that's in the denominator. So both of these have radicals in the denominator, and we learned in the last section how to deal with that. We multiply by the number 1. So I'm going to multiply by the radical over itself, or I over I. So what happens is in the bottom, I get I squared, which of course is negative 1. Now in the bottom, or in the top, let's just see what we get. We get 5i when we do the distributive property, 5i minus 3i squared. So that would be 5i plus 3 all over negative 1. And then another way to write that would be to go ahead and divide the negative 1 into everything, and we get negative 3 minus 5i. Typically, we like to write the real part first so that it's in a plus bi form. That's called a complex number. Now, on this last question here, we are going to multiply by the conjugate, just like we did the last section. 1 plus 2i over itself. So on the bottom, I get 1 minus 4i squared, which of course is 1 plus 4, which is 5. I know I did that fast, but it's just like, I replace the I squared with negative 1. So you get 1 plus 4, which is 5. Now on the top, you will have to go ahead and FOIL it out, and we get 5. And then we get on the outside 10, on the inside 18, so plus 18i. And then here's where the I squared is going to come out again, plus 16i squared. So 16i squared is really negative 16, because I squared is negative 1. So you combine that with the 5, you get negative 11 plus 18i. So I'd be okay if you leave your answer like that. I'm going to zoom in here for a moment. Or even better, if you want to write it in the complex form, you would write negative 11 fifths plus 18 fifths, and then a big I like that. That turns it into a plus bi form. But I will accept either one. And then I have a little comic here on the screen. So hey guys, you want to meet my new friend? Sure, but where is he? Oh, well, he's right here. Why can't anyone else see you? Beats me. Get it? He's imaginary. All right. Good luck on your assignment. Take care.